So first and foremost, welcome back to the R-Class Roundtable. With me today, my name is Dan Edelman. I'm the National Business Development Manager. I pretty much work with builders, architects, installation contractors, and basically everybody who wants me to work with them in the U.S. market. So I'm all over the place. Right, currently I'm up in northern Vermont, staying at my favorite bed and breakfast. So I hope that my Wi-Fi is strong enough that I could be on here the entire time. With me today, I'm going to start with who I was with the last 24 hours. So,
hi guys, I'm Nick Stone. I'm the Business Development Manager for the Northeast. Like Dan, I also cover builders, architects, just trying to drive that exterior insulation package and vapor open systems and try to help people build better systems.
And then to his south, we have.
I think that's me. I think I'm to his south. My name is Chris Caparucio. For those of you who have not seen me on these before, I am also Business Development Manager on the team here with Dan and Nick and a couple of the other guys on this panel. I'm going to be in the background trying to field the Q&A portion of this. I'll pop back on, and if I'm not able to answer it and pose a question to the panel, if that kind of works itself into the way that we're, proceeding through this as Nick and Dan and the guys make this happen. So I'm going to disappear, but if you see me again, well, you probably will see me again.
All right, and then to his west.
I'm Michael Crane. I also cover the South. Like these guys, I'm a business development manager. I work with builders, architects, installation contractors, framers, really discussing wall assembly designs and, like Nick said, to make buildings better.
I'm Chris Jessen, also a business development manager up in the North Central, handling kind of the whole middle, upper north of the country, kind of just south of Randy, but a little bit better. Do the same thing as everybody else, as Nick and Michael and Chris, so I will be in the background also.
Sounds good. And then, as usual, we have basically 3 different climate zones on today. We're going to be discussing the water control layer today. So water control layer, I'm going to say that it's pretty similar throughout the climate zones, but it's going to depend on some other factors. So starting up in this, actually, I'll pass it over to Travis and Joe in the middle of the country.
Middle of the map, the mighty Midwest. Hailing from Prairie Village, Kansas. Yeah, I'm Travis Brungardt with Catalyst Construction, and I work with Joe when he can tolerate it. What do we do, Joe?
We do high performance new construction and very, very good remodels. High performance when it makes sense on those also. Yeah, we're freshly back from Vegas, and I'm gonna shamelessly plug it. We're heading to the Northeast here in a couple weeks for our BS and Beer Symposium. And that's the 23rd, 24th of February. So if you'd like to join us, go to bsandbeerkc.org and get your tickets.
Awesome.
Good call. The Mid-Atlantic Building Science Symposium. It's going to be excellent.
And yeah, ROCKWOOL is one of our generous sponsors. So learn more about their vapor open assemblies.
Yeah, and then to their north, we have Randy Williams.
I'm the building science nerd from northern Minnesota. I perform energy audits, building diagnostics. I do a little writing here and there. And I also was in Vegas with those 2 fine gentlemen, Joe and Travis, presenting a few times at the High Performance Build Zone, which was a lot of fun. Yeah, happy to be back home now, though. Yeah, catching up on some work.
and brand new is Randy's blog on the rclass.rockwool.com. You can check out all the articles that he's been producing. So those are just really good, informative, typically anywhere from like a 3-minute read to an 8-minute read. So pretty quick, and get a lot of building science education that way. We also have the video library with everybody on here contributing to that as well. And then down in Atlanta, we have Chris.
What's up, everybody? I am just a nerd, period. But I'm kind of architect turn architect builder turn architect builder building science geek, and also HVAC design. And we do kind of consulting. We design the houses, build them. We work with people all over the country and now the world, and helping build better and fix problems if necessary, but try to build and educate about building right from the start, and saving some energy and being comfortable, healthy, and not killing our clients.
And then I'm actually going to pass the mic over to Nick Stone, who's going to be kind of going through everything on the control layer. So Nick, it's your mic.
Awesome. All right, guys. Well, today, as Dan said, we're going to go over our last control layer, which is the water control layer. Now, as I've been thinking about this control layer, at first I'm like, well, this is kind of a boring control layer. But as I started really kind of opening this onion up, there's actually a lot to this. So I want to start the conversation off with Travis. And Travis, in your opinion, where is the water control layer in a wall system?
Well, it's typically in a situation like what you have shown there, you're controlling it with your exterior cladding first, but we know that it's going to get past that. So the code dictates that we must have a weather resistant barrier behind that cladding. Is that the answer you were looking for? Are these the droids you're looking for?
So when I was thinking about this initially, my brain went immediately to this exterior siding and taking care of the bulk water and all that. But then, as like you said, we have to expect something is going to get by some of this. And then I started thinking, what about open rain screens? And Chris, why don't you kind of speak to some of this? Where I'm sure when it comes to design, you're seeing more and more options in the exterior part of it that is actually shifting some of the load, if you will, perhaps onto this WRB with these open rain screens. So Chris, can you talk a little bit about that?
Well, yeah, the water control layer is sort of an opportunity for us architects and us builders, but it's a great way to primarily it is bulk water control. It is our primary control layer. It's the number one control layer. It is, when you talk about the four control, water, air, vapor, and heat, it is the first one, and it's on purpose the number one layer because waters kills a building. Three main reasons for building failure, Travis?
Water, water, and water.
Very good. So water is first, and then air. But yeah, so the idea with the rain screen is that it gives us an opportunity to let any water that gets past that water control layer to get it out. So it's sort of a backup to our water control. Water control is just to shed that bulk water away from the building. It can be the cladding. It could also be the grading around the building. That's a bulk water control layer. The gutters are part of that control layer. It's just getting any of that rain, bulk water, and fire hoses when you're having fun, keeping that water out of the building. So it's number one. And then we have our backup system. And then after the rain screen also provides helps with the thermal control. So adding that layer helps improve thermal resistance of our insulation layers, and just having that air gap and in between the outer layer and our insulation layers. So there's so many things that rain screen can do. And then if it gets past the rain screen, that gap, yes, there is a water resistive barrier that will help as a secondary backup.
And Randy, when you go from having what I call a two-dimensional wall, which is what which would be if you're having conventional plywood with no exterior insulation, a siding being applied to it, versus a three-dimensional wall, which is I'm calling that does have exterior insulation, has those windows pulled out. Do you have the same materials on the vertical versus the horizontal areas from when we're talking about bulk water?
So you're talking a buck, right? A window buck that you're sliding that whole window assembly out. And then how do you flash that, correct? Is your question?
Yeah.
So ideally, you're going to start with the window rough opening, that buck. You're going to tie that back into probably the sheathing. You know, it all depends. It depends on the assembly. You know, is your insulation layer, is that going to be part of the water management, or is it actually just the insulation layer? Is your WRB built on the sheathing layer, or is it pushed all the way to the outside? So there's a lot of different ways you can go with this assembly. It really depends on the insulation. But let's take a ROCKWOOL exterior insulation, for example. So my assembly is going to include some sort of a WRB at the sheathing layer. Whether that be mechanically attached, it could be my preference would be either zip or an adhered membrane. You know, it's sticky, a big piece of tape that goes on that. That's my preference. Just because I can get an air tightness quality or an air component to that assembly as well. But all that's got to tie into the window opening as well. You know, it's all got to be water resistant, waterproof before the window even goes in, before the insulation gets installed. Once that insulation or once that window gets installed, now you've got a secondary flashing that has to go on, right? You have to make that assembly waterproof or watertight. That may be a metal flashing cap on the top. It's probably got some tape associated with it, sealing that tape to that window buck. So again, there's different ways to get to this end game. Just knowing your assemblies, understanding where the water's going and how it's moving, that's key.
So Joe, would you consider your primary water control layer at that point, assuming that we're getting some bypass, to actually be that WRB location, or would we consider that the secondary layer?
Oh, it's a good question. So yeah, if we were doing exterior, and for the sake of it, ROCKWOOL, that's my most recent job. We did stucco. I would say my primary one was we did a dimple mat on the outside of the ROCKWOOL, and so I would call that my water control layer A. The B is the ROCKWOOL itself, because it kind of is free draining and will dry out. And then C would have been my exterior sheeting. And we used a zip product, but you could use a plywood and use another weather resistant barrier right there.
Right. The when I was kind of thinking about these control layers, there's really a lot of water control layers in these systems, because if you think about it, even a plywood or OSB is also another form of protection from the bulk water from getting into the cavity. Obviously not the best. It's more acceptable to moisture and issues, things like that. But technically speaking, it would be. What are your thoughts on that, Travis?
Well, anything that can take on water is kind of a crummy barrier to it. It's sort of a transmission surface or a throttle. It's going to slow that water's entry, but unless you're dealing with something that like a zip, where it is an OSB sheathing, but it has a coating where you're actually not taking the material, you're not transporting the water through the material. Then plywood or OSB, they're actually going to bring the water in. They're going to wick right through. So it's not going to be bulk water at that point. It's going to move to more likely a vapor state, but without a taped seam or a liquid flash or some other joint sealant to keep the water from going through all the transitions and the joints. I would not consider a sheathing to be part of my weather resistant barrier unless we were talking about the coating on a pre-applied WRB panel.
Nick, I wanted to add. Oh, an echo. Just to add to that. Can you all hear me twice?
Yeah, it's the AirPods. I had to go to wired for that reason too. It's frustrating. But if you want, I can translate. Go ahead with the echo. I got you.
Here, we'll
Here,
just
we'll
do
just do it.
I'll just do it
We'll
like
just do it like this.
it's still an
Still an echo?
There is. Where are you taking bids? How many bids are you up to? Is this the Time Life books? This is what I ordered.
Oh boy.
Oh boy.
Should we just
Should we just come back to
Hold
me?
on.
Hold on a minute.
We'll come back to you, Chris.
So I as Chris is
There
getting
we go.
ready,
Can you hear me?
um,
Is that better?
Yep.
Okay. That's better?
yes.
Only one
Oh, now I'm
sealed.
muted.
No, you're
There.
good.
That was good.
That was good?
Speak freely.
Oh, there. Okay, got it. I wanted to just say, Nick, to add to that, there's something that I think just a takeaway here, something critical with this water control layer is we're talking about all these backup systems. And I think what's important with this water control layer is that get it right, and then these backup systems aren't needed. And it's really important to focus on this outer water control layer, the bulk water control layer first. Get all of that continuous and get everything away from the cavities. I don't think we should really say, well, we've got all these backups and backups. It just leaves us, it takes away attention from getting the outside right if we allow ourselves to say, hey, we've got backups, because those backups can fail and then fail and fail and fail. So I think I'm just saying in an ideal world, we're all going to be experts in a good water control layer that prevents the bulk water from getting prevents it from even getting to that rain screen. And the rain screen is there for ventilation, to help our assembly and perform well, both from a moisture standpoint, vapor moisture, thermal, and it's that's all. Just make sure, get that outer layer right, and that's the most important thing. Takeaway here is not to rely on the backup systems.
No, I totally agree with you. That primary, that exterior siding is definitely something you want to get nice and tight. Keep those joints tight. Make sure that you have the ability to keep that bulk water out. Have a nice WRB behind that. But absolutely, first things first, which is that exterior part of it. Now, I wanted to move into some of the details of that outside, is what you just said. That what is those outside problematic areas? The first one being the window. Dan, if you can go to the next slide. And I wanted to talk a little bit about when it comes to those door and window areas, what are some of the things that you guys are doing to kind of help protect, keeping that water kind of away from the building? One thing comes to mind for me in that lower left-hand picture. Joe, this is Joe and Travis. This is one of your projects. When I look at that picture, I instantly think of that overhang, and bulk water. Can you talk a little bit about that?
Yeah, the overhang's key. Travis and I are always, and I'm sorry, Chris, we're always trying to get an overhang on our projects. And then, the next step is we bucked out all the windows on that, and we were just diligent, oversight with the caulking the buck to the wall assembly, and then taping everything. I mean, we used a ton of tape. Really, you get one shot at that detail, because after we're done taping, we're putting insulation on there. We're going to put another drainage membrane, and then we're putting stucco, and to dig back in there to make sure that, if we had a failure, it's a huge expense. So kind of to Chris's point earlier, make sure you do it right the first time and really pay attention to the details.
Mm-hmm. And
nothing wrong with a good overhang.
Thank you.
And Travis, kind of going back into talking about wrapping that window, what was your detail there so that viewers can kind of understand what that was like?
Sure. Because we were using the ROCKWOOL Comfort Board exterior insulation, we had to buck out our windows anyway. So we chose the thermal buck product for that to limit the thermal bridging at the windows. So we started with that buck being actually taped back to our zip system sheathing. So we already had continuity to that point. Then when we added our windows, they were a flanged window that was surface mounted to that buck. Then we went ahead and taped over that. So we have essentially created continuity from the window itself back to the WRB. And in this case, I don't think we even put a flashing on the head of this window. There's frankly not any need for one. We built a roof as a flashing in this location. But on the areas of the house that had more exposure, where the overhang was further away from the window, we did integrate flashings that cut through, just as in your other beautiful project pictures there. I guess you would say second from left top, where you have a head flashing that wraps over the face of the window trim. In that case, it looks like probably a window, or that could even be a door trim there. But that head flashing needs to return back to that WRB, and for us, take to that zip system there as well. Now, because we have on that particular project, you can see that we had that dimple mat for the stucco. We're really extremely low risk in all those locations because we have those additional layers out. And I think that speaks to your initial point, Nick, where, yeah, the overhang's fantastic for that protection, but in every other location on that house, we have these redundant systems where we're constantly kicking water out and giving it a place to go. So where we don't have a big overhang, we have a nice head flashing. Where we do have a big overhang that's right on top of the windows, there's no flashing required because the roof and the overhang are the flashing.
Right. And I know for a fact, because I also helped put some tape on that building there, and you had some serious tape layers going on.
We like to stack them up. We spare no expense for our clients. Come on now.
Yeah.
Oh, absolutely.
One shot.
Yeah. Just on a quick side note, you guys can't see it there, but on that left side, there is a massive, was it a slider or was it a window there?
It's windows. We don't have sliders on that one. We just have free swinging doors. But yeah, there's a very long length of glass. I want to say 14 feet. 3 windows make up that space, 2 operators and 1 fixed.
Yeah, to set that window, we had to use a lull to like get it up into position, and then there was still 5-6 guys to kind of slide it into position. It worked out well, so it was a fun experience. So
that was my first time ever helping put a window in that large. I have to admit, I was a little nervous about, at the time we were ready to lift it, the 6 inches onto the frame. That was a very large window. But very cool project. And Randy, when it comes to going over the doors, would that flashing detail change at all, or would it be the same as your windows?
It's pretty much the same. You're dealing with the same, effects of moisture. They're going to come down as long as, again, you don't have that big overhang to protect it. I would still put the head flashing on whenever possible, and forget that exterior insulation. Of course, you got the buck. You're going to be, in most cases, you're going to be taping back to your sheathing layer or your WRB if it's at that layer. So yeah, everything's the same pretty much. Pretty easy. I mean, you're just repeating that same process around the house.
And like you said, Randy, that head flashing is typically tied back to your flashing. I've done it sometimes where I've got two head flashings because I've done 6 inches on an exterior, 6 inches of continuous insulation on an exterior wall. So I had sort of doubled that up. But it always ties back to the sheathing layer because moisture can get, if moisture ever gets to that, but then you have a way for that to find its way away from the building rather than down the wall. It just has one way to get before it hits the window. Of course, with the exterior insulation that thick, we're not worried about condensation because we've moved our condensation risk lines well away from the sheathing. But back to an earlier comment about overhangs is that the idea as we start to build thicker, wall assemblies where our continuous insulate, this isn't a jab, by the way, Travis and Joe, I'm just saying.
I'm bracing for it. What do you got?
Bring it on. We got a show. But the continuous insulation provides us extra protection as well. We've had it up to 8 inches, maybe 10 inches sometimes, depending on our rain screen and our cladding material. But that provides us another 10 inches. But again, back to the whole, let's get the outer layer right. When you get that flashing, all that flashing you guys have done with the tape and the counter flashing and the head flashing and all that, when that stuff's solid, roof overhangs, they're great. They protect the window from getting wet so that you don't have to clean them as often. They protect, the bulk water. But if those windows are installed properly, if you've got all your flashing done right in from the beginning, that overhang is not really serving any kind of purpose for that, because you've done such a great job with the flashing to begin with. So you don't need the overhang for that. And that's why I've said, hey, well, we don't necessarily need overhangs. We can deal with that all with our flashing material. And then where if overhangs aren't necessary because it's facing north, let's say, or it's, we don't need it for sun, or we don't need it, and it just calls for it. Well, take away the overhangs, and sometimes you take away those penetrations and you can have this kind of nice solid continuous box. So it's just an argument for, you don't always need the overhangs to protect. If you do it right from the beginning, like you guys are always doing, you guys are rock stars with it, it's gonna be protected right where it matters. It's right at the window.
Totally fair. We mainly push for that because it just lowers our risk. It allows for somebody to make a mistake and not ruin the whole thing. But you're right. If it's done right,
I always wear the belt and suspenders. I always do.
What about sock garters? How do you feel about sock garters?
I wear it all. If there are 3 ways to brace a wall, I'm doing 4. Okay, it's just how we do it. Make sure.
Dan, if we can go to the next screen, or the next slide, sorry. Here you can kind of see better some of these head flashing details, where you can see where on the outside of that trim board, how it does go all the way back to that WRB there. Now I do see a lot of guys just flashing, taking that 5/4 drip cap and just going straight to the strapping and then over the face of that. Chris, I'm actually curious on your thoughts on this one. Which one would you prefer?
The one on the right, you mean?
Yes, the right side.
Yeah,
sorry.
yeah. No, I again, if you're to do it, to manage all of everything that could happen at the head detail, or at the head, or even at the jam, or whatever, having the flashing go all the way back to the sheathing like that, or to your WRB, is going to give you the best control of sort of a one stop. The belt and suspenders right there, you have some moisture coming down from the rain screen itself or behind the cladding, or, I mean, that's nice to have, but it's absolutely not necessary. That one piece of flashing that ties back to the WRB and goes over your trim, that's doing its job. That's what it's there for. So I think having both of them, you could do, if you had a big overhang like Travis said, you could do just the one to the outside behind the cladding, but it's absolutely best practice to go all the way back to the sheathing, no matter what.
Yeah, totally agree.
On that detail on the right, you've got a little wood cap under the bottom edge of your comfort board there that I would like to omit in favor of free drainage and drying there as well. I know that that might just be in section, like there could be breaks in it, and a rain screen application probably allows a discontinuous nature there where you'd have some weep. But that drainage and drying is a twofold benefit. It's one of the nice things about obviously the vapor open properties of the ROCKWOOL is you get that sort of additional drying. The more access you have to it, and since the pests won't get into it anyway, unless you're looking at something there where you're not at bottom of wall, but it looks like above a glazing where you'd see it from below. That's the only thing. I guess that's probably above a window head is what that's meant to represent, isn't it? My mistake. Yeah. Sorry, I'm new here.
It's a good point, though. That depending on where you put that flashing, though, Travis, if that flashing was higher, let's say, and you tied it back in, say, 2 feet up, there's still 2 feet of sheathing that could sweat if you don't have enough insulation, or something could happen back at that layer above, say, your 14-foot long window, where you have all that 14-foot wide by 2-foot high strip of moisture that you don't want to get into the house. So having a way for that moisture to get out is good. But again, if your windows are done properly at the head, there's no risk of that moisture getting in. So, I mean, again, all this is belt and suspenders. Primarily get the one control layer, get it all correct there. But I've dealt with what you're talking about, is what do you do with that piece of trim, that return, and then the gap between the window and that wood? You want to tuck that in so you'd have nothing. You're not seeing anything, right? You're not seeing insulation or air or whatever. So we've come up with ways to fill that gap with, like, a rain screen, the mesh with the unchecked screen on the one side. It's black, it sort of goes away, but you still have the gap for it to ventilate,
It's an argument for the Audi window. You simplify that when your window's out front. I was going to pick at you, Chris. I can't resist.
A little bit turning the knife.
Awesome. So, Dan, if you want to go ahead and go down 2 more slides, I'd like to talk a little bit about the connection between the house and like a rim board. You can see here on the lower left-hand side, you can see how they pulled it away from the wall. On the upper left-hand side, you can see where they did more of a drip cap style on top and a kick out. I just want to kind of turn it over and just kind of hear your thoughts on those 2 spots.
Dan, if you'll go back 1 slide for a sec, this will address your question, Nick. The bottom left image right there, one way to do it is a complete separation of structure. So that's a project in North Carolina that we did. That's the deck. That's literally separated from the building, and then we used trivial amount of anchoring into the house, so it gave it that rigidity. But essentially, this deck could stand on its own. But in order to help with some of that pivoting right there at that connection, we did tie it back into the structure, and we're talking just some lag screws, lag bolts going back into the house. That trivial amount of thermal bridging. But you can completely separate it like this. Same with that middle picture where the slab is 2 or 3 inches from the wall. We just basically isolated the slab so it's not connected to the building. This helps with moisture. It helps with thermal heat transfer. And then that next slide, that go down, Dan, 1 more, and then I don't know whose that is, but they're using steel spaced at intervals so that the insulation can fill up everything in between. And so that's another way to do it. That's a really good way, because again, minimal thermal bridging, but still a way to solidly connect it without being continuous and interrupting your thermal control layer if you have it on the outside. So anyway, I like that steel detail there.
So that's a main to deck bracket, it's called. Or sorry, a main deck bracket rather. Awesome detail.
Yeah.
I think they make those out of fiberglass as well now to limit the thermal bridging. It's a different manufacturer, but I've seen that on other passive house projects that I've read about. It's pretty robust.
We've done it with wood blocking, and we had a client who they said, well, why don't we just use foam board behind the ledger continuously? The only drawback, I went with it, Travis. I said, you know what? Anyway.
Roll the dice.
I just said, all right, let's talk about that. And it's not, the thing about foam, of course, it doesn't allow moisture to move as much inside in a cavity or in a situation like that. So if there is moisture it could trap it behind that. We're not talking about a large area, so if you're an overthinker like me, every inch, every little bit, every time I see even just a little bit of contact like that, I think about it. But in reality, there's going to be it's vapor. Vapor can move through that insulation, so it can still perform. So that's another way to do it. You have to make sure it's good type 6 insulation or type 4 insulation. Make sure it's got good compressibility or compressive strength. But that could be an option. But I think the blocking with the stone wool in between the blocking is ideal for moisture movement and to maintain your fire resistance and insect resistance and all that.
Nice. Now we've talked a lot about the wall. When we start talking about the roof system, what kind of options are up on the roof system as far as water control layers? Joe looks like he wants to take this one. I see.
I was just looking at yeah, I'm sitting there looking. It looks like in the bottom picture they did the whole thing in ice and water shield, which is definitely an option. It kind of depends on your budget. On our most recent house, we did a peel and stick over the entire roof layer, and then put our shingles on that. Traditionally, a lot of roofers still like to use a layer of tar paper, and then you'll use your ice and water shield 3 feet back from your exterior wall. We've had success with all those methods. We did work on a project years ago, and it's actually for a family member of mine who has a really, really nice house. And I'm pretty sure, I haven't verified it, but I think the builder might have put Tyvek over the roof to as the instead of tar paper. And I will say it's also holding up. She doesn't have leaks, but it is, my recommendation would be at the very minimal, use your tar paper, use ice and water shield in all your valleys, and then go with a good quality roof, at least a 30-year asphalt roof.
Right. The one comment that really stood out to me was what Chris said, and honestly, until right now, I had really not thought of this, Chris, this way. That control layer from going from wall to roof by having no overhangs, that actually is a really nice detail. I never thought of it from that perspective before. I was always thinking from the shedding of the water away from the side of the building, but that's a really nice detail. You can kind of see how if you came up and over on the right-hand side with no overhang, how just spot on continuous that could be.
Yeah.
Well, and
yes.
you can handle that overhang by, like what Joe and Travis have done, and we've done on several projects, is just bury your overhang material, your rafters, your outriggers in the insulation, so they're still outside of your control layers, which is your sheathing that continues, but it's outside of that and separate, so you still have your continuity and an overhang, so you're getting both. But it kind of only works if you're doing continuous insulation, because then you can wrap the outriggers in the insulation to keep the thermal expansion and contraction to a minimum.
Absolutely. Chris, I see you have popped on. There must be a question.
Yeah, and it's directly related to this page here. When Joe, you referenced the picture with the ice and water, even though this is talking about vapor and not exterior moisture or rain or wind-driven water, isn't it a bad idea, or couldn't there be a school of thought where it's a bad idea to use a totally vapor closed product like in ice and water in that application? Tough one. Sorry, I don't come in for the easy one.
I don't believe so. I mean, and you feel free to jump in, anybody. I think it'd be, you're fine to do that. You're really wanting to manage your moisture in your attic, your venting.
Mm-hmm. Yeah, the ideal is to have, like, if you are doing a peel and stick, I've actually done some research because we have these multiple pitched roofs where we're trying to do the assembly. I think you guys did this, Travis, where you have sheathing, insulation, and then more sheathing on top of that. And when you get into those, when you get to something below 312, you need to have a more vapor open assembly for that, just because the vapor doesn't drive its way up to the peak near as well. So as you get shallower, even the code says something about this. So you can't use, so the vapor close, even the vapor ridge vent doesn't affect it. So you're dealing with, and so I've done research. You can't, like, there's very few there are in fact no products out there that are vapor open that you can use on a less than 312 pitch. So you're dealing with trying to get your ventilation in there. So you have to do some kind of furring strips on top of that assembly still to get your vapor to be able to ventilate, to the ridge, or to get it away from the assembly. So, but for the most part, having a vapor vapor closed membrane like that is definitely better. It's a more robust, and I think the code doesn't require it for the full assembly, as you know. So, but yeah, it's a really good assembly with it there.
Yeah, I think the important point there is it has everything to do with the intent for your attic. If you have a conditioned attic and your roof deck is your air control layer, well, now it's a fantastic choice. That peel and stick isn't going to let any vapor or air through it, and you're essentially solving your vapor on the interior of the system now, which can be done a number of different ways. Although Chris does make a good point, the code has some really muddy language about that. That depending on the way that you choose to read it, yeah, that's right. The way that you choose to read and interpret that, you may find yourself with a peel and stick layer on top of a continuous sheathing, continuously taped sheathing, and a nice vapor open product to the interior, and a conditioned attic that is totally code compliant. I know a couple of really good builders in the Midwest that have done that on a very high profile project with great success. They're really sharp guys. You should look them up. Anyway, I digress. The issue with vapor discussions always returns, in my mind, to the source of the vapor, and addressing the source of the vapor is probably your best strategy, rather than worrying about whether or not your peel and stick is going to stop 3 feet short of the ridge and you're going to add a little strip of Tyvek for your vapor diffusion ports. Like, there's a lot of real gymnastics being done in terms of physics there to make it work. As you rightly pointed out, Chris, that 312 pitch is sort of a magic number in order for that to work. And those ping pong moisture articles that are so frightening really rely on a volume of water vapor to begin collecting and condensing to actually create that issue. So I feel like I should talk less when Randy Williams is on, because he's so much smarter than I am. Did I just say anything that's a lie, Randy? Because I was intending to be honest and truthful in everything I said.
I think with the question, there was an article on Green Building Advisor I remember reading. I think Martin Holliday might have written it, dealing with the ice and water shield, continuous up the roof, a roof sheathing such as OSB, and then closed cell spray foam applied directly to the bottom side of that sheathing. And I think the concern was no drying potential at all on either side of that assembly, where you maybe, if you do have a moisture issue, it becomes a problem. Again, it comes down to where's that moisture coming from. If you've got enough, hopefully it's not there to begin with. Hopefully you're not spray foaming that stuff into the roof assembly as you're building the assembly. But I think that as long as you're providing enough insulation below the roof deck, I don't think it's going to matter either way. I think it's going to stay dry.
So once upon a time, there was a building assembly that was being attempted. I mean, people can still do this, but the perfect wall and the perfect assembly was an absolutely vapor closed WRB with insulation to the outside, and that's still possible. It's changed. The conversation has changed to where now that vapor openness is a good thing, because what happened is there's been some errors in that logic. So people were applying that, and then they weren't putting enough exterior insulation on there. So now they're saying they're recommending, let's do vapor open to be more forgiving to the industry, so that we can screw up a little bit more, like not put enough insulation to the outside. So if we put enough to the outside, every woofy model that I do, that, you know, the hygrothermics tell us that, oh, if you put at least 1.5 to 2 inches on the outside, anything beyond that, you're golden. We don't even have to run the woofy analysis, because we know that that's going to put our moisture control layer or moisture risk line in a safe spot. And so it's just you can still do vapor tight all the way around the building, as long as you have the right amount of insulation and you do all your other control layers properly. So it's just like everything in this, it all depends, right?
And it ties right into this building science investigation, right?
Here we go.
I tell you, I've been so excited to get this out ever since Randy sent this to me. I think all of us just truly enjoy building science in general, but when we can see a project and break the numbers down and look at the raw data, it's so much cooler. So the question is, 2 inches of closed cell spray foam, will it stop vapor diffusion, right? It's closed cell, it's got to stop it. Randy, I want you to take this one over. Dan, if you go to the next screen, you want to give a little background and kind of go through this one. This is a very cool project you worked on.
Yeah. So this was a building diagnostic I did. Actually, it's only been like 2 or 3 weeks ago that I was at this project. I was called in because the homeowner had water dripping out of their ceiling in the middle of winter. So we would get a little bit of a warmer day, and then some water would start dripping out of it. They had a tongue and groove ceiling. It would start dripping out. And I got there. I mean, there was some issues with the house right at the bat, which we'll get to in a minute. But the tongue and groove ceiling, and the homeowner said that a spray foam contractor came in and installed 2 inches of closed cell spray foam right to the wood paneling above. Okay. No other vapor retarder or barrier, nothing, no poly or anything like that in place. And then they blew a bunch of fiberglass insulation on top. When I got there, we found that the house was running, when I got there, was like 46 or 48% RH, which in my climate, it was like 0 or something like that. I don't remember what I put in there, 0 or 10 below or 10 above, something like that. Outside temperature. Anytime you got an outside temperature that cold, the windows will automatically become, I don't care if they're triple pane, they will become condensing surfaces in my climate with an RH that high. So we knew we had a moisture issue at some point. We were able to track that to a crawl space that did not have a poly down on the floor. So we were just taking ground moisture, and it was just funneling up through the assembly. And that's where our the moisture issue inside the home was coming from. But it still didn't answer the question: is how was that moisture ending up in the attic? You know, was there a bunch of air leaks present, which I was able to do a blower door test to find out, or was there some other mechanism happening? Blower door test. This was a house built in 1980 with an addition that was a couple 3 years old. The entire thing, as I said, was spray foamed in the attic. The blower door test was like 3.4. It's right there, 3.43 ACH 50. So that's really good for a 40-year-old house. I'm happy with that. I did notice that there was a lot of leakage low. It was coming out of that. It was the crawl space was a vented crawl space. They plugged the vents up in the winter, but that's where a lot of the air leaks were. The lid was actually pretty tight. There was one spot that I was able to see a little bit of air leaking. It was where the addition and the original home were mated together. There was a spot right along there, but it was just a very sliver of a air leak that was able to detect with thermal imaging with the blower door running. So I got to thinking about this. I went back to Building Science Corporation and I found that an article written by John Straub, where he said that 2 inches of closed cell spray foam may not be enough if you have more than 10,000 heating degree days in your climate, which is what I have, and you have an RH, interior RH of right around that 50% level, which is what we had also. I think this ended up being my first ever vapor diffusion issue, where we actually had vapor moving through the closed cell spray foam into the attic system and then forming on the roof sheathing, and in the warm days it would melt and run into the home. So, interesting. It was fun. It was a fun one to do, but you know, kind of an odd situation that I haven't seen before.
So how'd you fix it? You got to tell us how you solved the problem, Randy. Come on.
It's not up to me to fix it. I identified the problem, and but what I recommended though to the homeowners, number one, you got to get that vented crawl space, make that a conditioned crawl space, and get that floor sealed. That's number one. You got to get that done. Number two, you should have some kind of a balanced mechanical ventilation system installed. We did have an elevated CO2. I had my new meter, my air quality test meter with. They were running almost 2,000 parts per million on their CO2, which is about double what's recommended. They did have a couple of wood burners in there. There were actually pellet stoves. I have a feeling that might have been part of the problem, but of course they were off in the blower door test. I wasn't testing those. The CO2 did drop significantly after 15 minutes of running the blower door, which you would expect. Flushing that stuff out of the house, we were down to 600 parts per million or something after just a few minutes running the blower door. So, but yeah, there's those two measures alone, especially sealing that crawl space, making that conditioned space, and then sealing that floor off. I think that would take care of their problem of the moisture. But indoor air quality is huge too, and being able to dilute what we are also finding there. Dedicated dehumidification, I love it. We're still required to have the balanced mechanical ventilation, which in an HRV will handle our wintertime loading. Of course, shoulder season, that's where you need dedicated dehumid. I don't think this homeowner is going to put it in unless there's a problem. You know, it's just too expensive of an additional cost to go with the rest of the build. So maybe down the road. Yeah.
Chris, LG has one in his basement. He'll send to you. Oh, wait, you don't have a basement. Never mind, my mistake.
You're mute.
It's where I keep corpses of people like you who just won't let it go.
Well played.
Yeah, so when Randy sent this to me, I thought it was really cool that, you can't just take, the average information. You really got to take all the factors that come into play. So in this case, it was total R value or thickness of the foam. It was relative humidity. It was the climate zone that you live in being so cold. The number of heating degree days added up over the course. And just kind of a cool statistics that I just had to throw out there was a family of 4 produces about 5 pints per hour, or a half a swimming pool a year. That's a lot of moisture just by breathing. And, a direct link to probably some of this relative humidity issues that these guys were having. But I just had to throw that half a pool in there because I thought it was such a cool little fact.
Well, and when you combine that with the leakage of most homes, which probably amounts to several swimming pools per day, especially in places like the South, you're having to deal with so much moisture. Fortunately, we've had some experiences here where, Randy, where you've got dry air pretty much year round up there. We, of course, it's pretty much the opposite. here, but because if your building envelope is, if you are paying attention and you do get all these layers correct and continuous, uninterrupted, we have all of our projects here. None of them have dehumidification, and we are in the southeast. And I think everyone on this panel and everybody watching this is wondering how we've not been in lawsuits from day one. But it's because of that air. It's getting your air control layer right, getting your insulation where it needs to be. But that air control layer is number 2 on your control layer list for a reason. Water, keep it out, but then stop the air. Forget insulation for a minute. Get your air control layer right, and you've got a high performance home if it's super tight. We've been able to get away with that because the moisture coming from outside is a huge contributor to our RH inside. We monitor these homes. We make sure that we're not at risk. But again, get that layer right, and then we're not dealing with what Randy had to deal with there, is too much moisture inside when it's cold outside, or when it's and because that vapor, if the vapor has nowhere to drive, and that's so if we have just our internal loads, there is enough in there to where we can, just through ventilation and air conditioning, we can control that moisture without having that supplemental dehumidification. It's always good to have it pre-wired just in case, but because you never know how many showers that teenager is going to take in a day.
Or that they bring in 50 house plants, or it's one thing that I always worry about is we lose control after we turn the keys over, and we just, having backups available, like you said, it can be installed down the road. If that system isn't available, then it's a lot tougher. It's a lot more expensive to.
Right. Yeah, I would say that's our biggest concern. Travis and I worry about that all the time. It's after we turn it over, we're like, are you going to be opening up your windows all summer? Like, what can we do to, manage that? So Chris, you're saying you monitored, you actually put sensors in the wall that you can, like Wi-Fi sensors that you can monitor after you turn the house over?
In the wall, in the attic, in the house, everywhere. This is a house in Roswell, Georgia, that we had monitors everywhere for about 2 years. South Face Energy Institute did most of the monitoring of that info, and we found that, and we also put our heat pump water heater in the attic, so it helped keep that dry. But all between that and the house measured below 0.5 ACH 50, and so we were able to control that moisture with the air tightness. And then the system, we sized the system so the air conditioning and the heating systems, but the air conditioning to be able to have enough latent capacity to be able to pull moisture out. So between that, the heat pump water heater, and the air tightness, all of that kept us from needing getting our RH levels too high. So it maintained comfortable, healthy, all that fresh air coming in and out all day long. So
that's
it worked
nice.
out.
Chris brings up sensors. Ben Bogey, when we were in Vegas, gave me one of these. I've since purchased 2 more plus a hub for these things. This is we'll have a little box opening.
Unboxing videos are huge, Randy. Hold on, let me get my camera.
So this is just a very small temperature humidity sensor. It's a HTW sensor made by Sensor Push. So it ties to an app on your phone, and it's constantly monitoring just the humidity, temperature, and then it'll calculate dew point for you. I've got one upstairs on my floor next to one of my exterior walls. I think the temperature there is right now 60 degrees or something like that. Of course, I'm a little cooler outside. The bottom of my walls get a little bit cold. I'll pull the app up so you can see it. So this is what it's reading. You can see all those jogs and line. That's every time my furnace kicks on, it actually oscillates the temperature at the floor level. But at humidity, I'm running, I've spiked as high as 36%. It's averaging right around 32% at the floor. And that's kind of why I'm monitoring that right now. I want to see our next cold spell, if that area of the floor drops down or if it's constantly staying right around that 30%. So handy little, they're about 70 bucks a pop. So they're not inexpensive, but I've got a couple jobs coming up, some diagnostics that I know I'm going to need these on. That's why I bought 3. So maybe on the next one, we'll be talking about that building diagnostic, and it's kind of a fun one too. So we'll see.
Randy, I've got this one. This one is one I recommended from someone at Build Equinox. But as you can see right now, we got painters in the house, and so my PM 2.5 is going through the roof. So I need to evacuate before I'm dead. But it also does, we got temperature and RH, CO2, VOC. It has a few others, but this is another really good one. And if you have RH and temperature, if you go to dpcalc.org, that's also a website you can calculate your dew point. So if you don't have something that can calculate like that monitor, I love that monitor. I think that's a really nice one because you can put it everywhere and then just read how the different rooms are doing. This is a little bulky. It does have an app as well, but it's cool. It's great to. I just know by the way, just a side note, when a candle is lit, by the way, y'all, the PM 2.5 goes through the roof in this house. Like we have a 1,200 square foot condo, and it's just like one candle. After about an hour, we're in the danger zone. So just something interesting to. We're not talking about that today.
Well,
Good segue.
Chris, looks like you're on. Maybe you have some questions for us.
I had one question specifically for Randy, and sorry, it's over here. So, do you have a recommended RH per degree rate that you would recommend? Specifically, the question is out of Ottawa, where they face around 4,500 HDD, and it was cold the other day, so negative 32 Celsius.
It's cold.
And it said that there was ice on the windows. So they wanted a recommendation if you can give kind of a range or something for them.
It's so variable depending on outside temperature. Like they said that day where it was that cold, 2-pane windows, if you're running in my climate at 30 below, 2-pane windows, if you're 30%, you're going to start seeing some moisture on the windows. You get up to 35% and you got a lot of moisture on the windows. Matter of fact, you got a lot of ice on the windows. It's not going to be just liquid, it's going to freeze. So it varies so much. You get down by Travis and Joe, they can probably handle a little bit higher. Those temperatures that they're seeing aren't to that really cold extreme. But when they do experience those temperatures, there's going to be some moisture. It's just physics. It's just the way it's going to work. So that 4,500 degree days, heating degree days, you're closer to Travis and Joe. You could probably run closer to a 35 RH. Buildings often, it depends. That famous line that building scientists have, it depends. The buildings can vary so much. The window performance, everything varies so much in it that really, you really have to kind of play with your house to figure out what works best, where that humidity level should hold based on outside temperature.
So Randy, something that might help this person or anyone is that what I just referenced before, the dpcalc.org, you can enter the temperature of the window, the relative humidity, and adjust the relative humidity up and down. There are scales on this website. You can just change temperature, relative humidity, and dew point. But basically, you'll know when you're at and then it has off to the right, it talks about natural aging, mechanical damage, mold risk, metal corrosion. These are the risk factors. And so as you change the RH, you can, and the temperature, you can see where you're going to see condensation, where you're going to see mold. So it's a great website for that kind of thing. So if you're in your house, everybody can check their own and just say, well, what's the temperature in my window? You might need a little laser thermometer. check the temperature of the window, the wall, the floor, and see where the RH needs to be to keep your dew point in a safe zone. So that's probably it. I mean, that's how I would recommend it. There's not really like you had a difficult really saying exactly what's the rule of thumb, what's the heuristic for that. This is the best way is just kind of do the math, put your numbers in and see where it's best.
When you're using a laser thermometer like that, put a piece of tape on your window, let it sit there for a little while to get to the right temperature, and then use that laser. That'll get you the most accurate temperature.
Yeah.
That actually ties directly.
Otherwise, you're.
Yeah.
Say again, Chris.
I said that what you just said, Chris, ties directly into a question that also just came in while you were talking. It was just for you guys to repeat the name of the monitors and the website that you had referenced just now. So that was really it.
Okay, dpcalc.org it's dew point calculator, abbreviated to dpcalc.org. And this is Kingping. What is it? Kingping. QINGPING is the monitor I use. I got it from Amazon, and it works great. Randy?
This one is Sensor Push is the manufacturer. They only make 3 of these sensors. One's made in China, one's made in the United States, and then there's one that has a higher range of accuracy. That one's almost $100. I just bought the American-made ones. They're $60, I think. And you can get them on Amazon. Yeah.
Awesome. Well, thank you guys so much. Dan, if you want to come on, I almost feel like Dan has to be on for the rock on part. You know, it's his signature move. If he was a wrestler, this would be his move. You know it.
Well, hey, thank you guys as always. You know, I think that we had a blast here. We got into water control, and of course, it always gets into the vapor conversation. You know, if you haven't seen the vapor control roundtable, I believe we did that first or second. I want to say first. So it's going to be part 1. If you go to rclass.rockwool.com, that's where all of these videos live, including the early webinars that we had way back in the day, back in 2020. And it's just a great experience for watching all the videos. We also have a lot more content on there. It was a pleasure seeing you guys all again this afternoon. And I guess till next time, rock on.
Rock on.
Rock on.
Take care, guys. I don't know who's
guys.
going to shut this one off because we don't have a actual organizer on this one.
Uh-oh.
Maybe it'll work. No, it works.